Hi everyone, welcome to challenge number 1. Here is the question. There are 20 points on a plane of which 6 are collinear. Find the number of triangles that could be formed using these 20 points. Let the 20 points be P1, P2, P3, so on up to P20. How many points are required to form a triangle? 3 points are required to form a triangle, be it isosceles, equilateral, obtuse, acute, right angle, or whatever. 3 points are required to form a triangle in this fashion. Well, so when does 3 points do not form a triangle? If they are collinear. What does it mean? That means the 3 points fall on the same straight line, as shown here. Now let us calculate the total number of triangles possible from the 20 points, out of which 6 are collinear. Because 3 points are required to form a triangle, and we have in total 20 points, in how many ways we can select 3 points from the 20 points? It is possible in 20 C3 ways, which is equal to 1140 ways. But the triangles are not formed if the 3 points selected are from the collinear points. We have 6 collinear points. So, in how many ways 3 points could be taken or selected from these 6 collinear points? That is equal to 6C3, which is equal to 20 ways. So, out of 1140 ways, in total, in 20 ways, the triangles are not formed. Therefore, what is the total number of triangles possible? That is equal to 1140 minus 20. That is equal to 1120 ways.